Hello and welcome to Jason Live. My name is Patrick Shea. We're back once again with our STEM career series where we connect you with role models in science, technology, engineering, and math. Today's STEM role model is Mona Behl. Mona is the research coordinator and climate change specialist for Texas Sea Grant's research program. In a moment, we're going to learn about the diverse roles she plays in this position, including conducting her own oceanographic research, coordinating the research efforts of others and funding them, and educating entire communities on the important work they all do. We're also going to hear more about the fascinating path Mona followed to get where she is in her career today. Before we get started, I just want to remind everybody out there that today's event is live and interactive. We want you to send in questions from Mona. We also want you to participate in our polls, which will be coming up later in the program. So we'll try to get as many of you involved in today's program as possible. Looking forward to hearing from you. Right now, it's time to hear from Mona. Welcome, Mona. Thanks for joining us once again.
Thank you so much, Pat. Pleasure
Awesome.
to be here.
So let's start off. This is a career role model event. We want to learn about your career as an oceanographer, but why don't we start with the very basics? What is an oceanographer and what do you do on a daily basis?
Sure. So an oceanographer is a person who studies the ocean. So you could study the physics of the ocean. That will make you a physical oceanographer. You can study the chemistry of oceans. That could make you a chemical oceanographer. You could study the geological processes and the geology of ocean. That makes you a geological oceanographer. You study the biology of oceans. That makes you a biological oceanographer. So there are these all different aspects of the ocean that you can study. And that's what makes you an oceanographer.
So we're obviously very interested in the aspects of oceanography that you are most interested in. We've got a couple of questions that might help get us down the path of understanding what exactly it is that you do. Grace Christian homeschoolers ask, what aquatic animals have you studied and for what purpose? And what did you learn? And Madison asks, have you ever worked with a marine biologist to study how light and temperature affect fish? So as an oceanographer, is it, immediately obvious that you would be working with marine critters like fish and things, or is it something else entirely that you do?
Thank you so much for those questions. Well, as an oceanographer, there is a possibility that a physical oceanographer might collaborate with a marine scientist, a marine biologist, a chemical oceanographer, a biological oceanographer, so on and so forth. But I study the physics of the ocean because my background is in physics. So I use my background in physics and my knowledge of physics to understand the physical processes that go on in the ocean. So unfortunately, I haven't got a chance to work with any marine biologist just as yet, but I'm looking at those aspects now in this in my current position. So yes, that's an interesting question, something that I have not explored at the moment, but there is a possibility.
Okay, Robert from Mrs. Powell's class asks, do you ever collect samples of sand from the ocean floor? So that's a bit more physical. Is that something that you would do?
That would be a physical or a geological oceanographer. In either of those, oceanographers could do that. In fact, I would say even a chemical oceanographer could study the sand samples from the ocean. I personally don't do it because that's not my field of expertise. But an oceanographer, yes, of course, an oceanographer could study sand samples from the ocean floor.
All right, so we've talked a bit now about the kinds of things that you don't do in your role. These questions from Caleb and Tori's class, I think will get us down the path of what you actually do. So Caleb asks, what methods do you use to study the physical parts of the ocean? And our next question here is, what scientific tools do you use to do this?
So scientists can either go out here and collect samples and data, and so that would contribute to observations. Scientists could also understand the physics and the theory behind it. So that would be that would lead to enriching the theory of any specific field. And then, of course, the scientists could model based on theory and based on observations. They run models. These are numerical models that tell us about that can tell us a lot about past climate variability and change. They can also tell us about future climate variability and change. These models reflect a lot and can tell us give us a lot of information about the Earth system, which basically includes the atmosphere, the ocean, the land, human beings and animals, and all the organisms that are a part of Earth system. So the methods that I specifically use, I call myself an analytical modeler, which actually means that I use my knowledge of basic knowledge of physics to write some fundamental equations of physics and use a lot of mathematics to solve the problem, the research problem. So my methods are mostly theoretical, unlike some other colleagues of mine who actually go out to the sea. I could do that, and that's something that I'm working on right now. But so far, my research has only been theoretical.
Gotcha. So you use math and models to better understand kind of the ocean as a whole. Is that fair to say?
Yes.
Awesome. So when I introduced you at the beginning of the show, I said you do a lot of different things there at Texas Sea Grant Program in your role. One of the things I mentioned that you do is your own research. You just talked about the methods, but why don't you tell us what the research actually is that you're doing on our oceans?
Absolutely. So my research is an extension of what I did for my PhD dissertation, which was trying to look at what effect does the slowing down of this huge ocean current, which is called thermohaline circulation or global conveyor belt, has on the temperature of Europe. So what you see right now is cold, salty water, which is much dense. It sinks all the way down to the bottom of the ocean floor, sea floor in the higher latitudes, and it begins to travel southwards towards the equator and lower latitudes. So it goes all the way down, hugging the North Atlantic, and then moving down to South America, and then it gradually rises up back again. So it takes about 1,000 years for this huge global conveyor belt, which actually forms in the entire ocean basin of the world, to run. So it takes many thousands of years for this global conveyor belt to run. So I looked at what happens if this conveyor belt slows down. So I wanted to see what happens to the temperature of Europe. Does it cool? Does it warm due to the slowing down of this huge global ocean conveyor belt? This ocean conveyor belt is very important because it ventilates the ocean. It brings all the nutrients from the deep sea back up to the surface waters. So it ventilates the ocean. It brings back up the nutrients and carbon dioxide to the surface waters from the deeper sea. And it also regulates the temperature. So there is heat that is exchanged between the ocean and the atmosphere that keeps the poles and the equator at the temperatures that they are at right now. So it's a very important part of the climate system. So my research is basically to look at what happens if this conveyor belt changes.
And do we want to know what happens? Obviously, we want to know, and this is what you're pursuing, but what is kind of the worst case scenario if this were to slow down or stop?
So 100,000 years ago, that is when there were ice ages. So the planet was, in many parts of the planet, Earth was covered with ice, and that had happened because this global conveyor belt was very slow. It slowed down by a great degree. So that led to the planet becoming basically covered with ice. So if this conveyor belt slows down, it will lead to a lot of changes in the atmosphere of our planet. It might lead to the poles becoming even much even colder than they are right now. It might even swing the system to an ice age. So scientists are at the moment trying to look at what the impact of this large-scale global ocean circulation is. But scientific evidence suggests that in the past, such changes caused huge atmospheric changes.
Obviously, very important stuff to know what's coming up in our future here. So we've actually have a couple of related questions from Mario, who I believe is watching our program earlier, and clearly was listening very intently as you described your research on the ocean conveyor belt. He wants to know a couple things. One, is the ocean conveyor belt slowing down? And does global warming have anything to do with it? And he also asks, is it true that as the polar ice caps melt, releasing more fresh water into the oceans, will it slow down or even stop the conveyor belt?
Sure, thanks for your questions, Mario. So as the global temperatures rise, the average temperatures of planet Earth rise, that they lead to melting of sea ice. And when the sea ice melts, it leads to freshening of the ocean water. So yes, if a lot of sea ice melts in the polar regions, that will lead to the freshening of the North Atlantic. And if the North Atlantic freshens beyond a certain degree, that leads to a slowing down of this thermohaline circulation, or the global conveyor belt as it is called. So it runs because of these differences. Thermo means temperature, haline means salinity. So thermohaline circulation is a density-driven circulation, and these density changes are caused due to the changes in temperature and salinity. So yes, if at the polar regions, if a lot of sea ice melts, which has happened in the past, it might lead to a slowing down of the thermohaline circulation, or the global conveyor belt. There is scientific evidence that suggests that the global conveyor belt might slow down in the next 50 to 100 years.
Well, we are not slowing down here. We're going to keep it moving. And so far, we've really just touched on one very important, clearly, aspect of your current career and current role. Can you tell us what other kinds of things that you do there at Texas Sea Grant Program that might be a little closer to home in terms of, more related to Texas coastal communities?
Absolutely. So I, of course, lead the Texas Sea Grants Research Program, which means that I manage the grants and fellowships and scholarships. But another exciting part of my job is that I get to do some action research as a climate change specialist. So this is where I actually work with the local communities and the local stakeholders and try and answer some stakeholder needs. So that's the part that entails action research. So this is research geared towards answering stakeholder needs. Of course, it entails education and outreach. So I talk to the people of Texas about their dependence on energy, economy, environment, and education. So those are the 4 E's, the 4E quadrant that I like to call is how we have conversations here with the coastal communities in Texas.
And there's obviously a large coastline there in Texas, and a lot of different activities taking place, both economic activities and stuff that folks are doing for fun. So what are some of the impacts that you're able to bring to the table, that you're able to talk about in terms of research and education that impact those communities?
Absolutely. So one of the major impacts that global warming or climate variability and change has is that it increases the temperature. So an increased temperature leads to variability in precipitation levels. And if precipitation means the amount of rainfall that a particular area gets. So if precipitation levels change, that obviously changes the availability of water. Texas has a unique geography in a sense because it has a coast. So it's a coastal state. It has a desert, so it's also considered to be a desert, and it has everything in between. So it has a unique geography in that way, and you have to talk to people about things that matter to them. So water issues are big in any region of the world, but there are especially critical issues here in Texas, where you have a lot of heat which is being added to the atmosphere due to climate variability and change that leads to lesser rainfall, lesser snow melt. So this leads to lowering of water levels. So the drought that Texas felt in 2011, we're still feeling the impacts of that drought in the year 2014. So the aquifer levels resulting from that drought have still not come back to normal. So there are a lot of issues that are occurring in Texas that one needs to address. I'd also like to mention that Texas has a big energy industry. So energy industry is basically the driver of Texas's economy, accounting for at least 8% of the gross state product. Now, scientists have predicted that there would be 1/5 of an inch increase in sea level rise in the Gulf of Mexico region. And while 1/5 of an inch may not seem like a big deal, yet it is huge. It is 5 times the average rate over the past 4,000 years. So if that rate of sea level continues to increase, there's a lot of oil and gas industry, a lot of oil rigs, a lot of energy infrastructure on the coast that can be impacted. And that, if that gets impacted, it kind of impacts the entire economy of the US and then the world.
Amazing stuff. We've got sort of a follow-up question here from Caleb from Miss Powell's class. You've described a lot of the different types of things now that you do in your current role. He wants to know, what would you say is the most important part of your job? Can you pick just one?
I think it's there are many parts of my job which I think are important. But if I were to pick one, I think that is to make sure that we address the needs of communities, the needs of coastal communities, the needs of inland communities. So we actually solve real world problems. Sea Grant solves real world problems. So I think that is something that gives me a lot of satisfaction at the end of the day. Just realizing that either by creating awareness or education, or by conducting some research, whether it is basic or it's applied research, or by talking to stakeholders and building partnerships. So using either of those techniques, I am able to make a difference, and that's something that's very important to me, and I enjoy it.
So you just answered what's the most important part of your job to you, but is our next question here from Ava, she wants to know, what do you like best about your job? Is the answer the same?
No, actually, the best thing about my job is that I get to learn. I love to learn, and as a physical oceanographer, had I been only an academic, I would have done research, which is absolutely amazing and great, and people should totally do that. But I am a person who loves to learn other things as well. So the best part of my job is that even though I'm a physical oceanographer, I get to talk to fishermen, and I get to talk to people who are working in law and policy aspects of the coast and the seas. And then I get to work with chemical oceanographers and biological oceanographers and artists, actually, so who want to integrate STEM and arts. So I get to learn something new every day, and I think that is just the most it's the best part of my job.
That's awesome. So we're going to looking at the time here, it's time to move along to the next part of our program where we're going to ask you about what brought you to this point in your career. You just described in great detail what an oceanographer does and what you do in your daily role and multiple roles in your current job. But folks out there are wondering how you got to this point. In our first couple of questions here, one from Bernardo, he wants to know what made you want to learn about oceans, and then students in Miss Week's class want to know what inspired you to become an oceanographer.
Sure. So I grew up in India, in a state called Punjab, which is right on the border of India and Pakistan, below Jammu and Kashmir. The star that you see is where I come from. It's very close to the foothills of the Himalayas, and I had never seen the ocean before I came to the U.S. for my PhD. I had no idea what oceanography was. I have my bachelor and master degrees in physics, and I thought with those degrees I could probably pursue more education and learn something about the stars and the planets, like many students in physics may want to do. So I applied for a few graduate schools, graduate programs in astronomy and astrophysics, but I couldn't get through. So I thought, well, if I'm not going up, I'm going down. And that's how I tumbled across physical oceanography. And I got in touch with my former advisor at Florida State University. And I asked him, is there some way I could apply my knowledge of physics to the oceans? And quite frankly, I thought that, it would be adventure. I might be able to solve some real world problem that I really wanted to do. It was just keeping an open mind and actually stretching out of my own comfort zone that I tumbled across oceanography and realized that we have this amazing association with the oceans, and this is a picture taken from on the Apollo mission. So as a physicist, I always felt that I was looking at the stars and the planets, and yet when you turn around the camera and look at planet Earth, it's a pale blue dot. Yet this is where life happens. This is where everything that we know exists. So it's a very profound place, and 71% of the Earth is oceans, and I have thoroughly enjoyed learning the role of oceans in the Earth system and how it interacts with different living beings and the atmosphere and land and everything. So.
And another thing I like about that is just how all of this science is so interconnected, where you can apply the physics that you learned that you wanted to apply to something else. It applies to the oceans, and there's so much there to learn right here at home. We've got our next couple of questions related to home, but a little, we're going to zoom in on that globe. Some students from Metrolina Regional Scholars Academy want to know, when did you come to the United States? And a guest asks, was it hard to leave your family to come to the U.S. for your education?
Good questions. I came to the US 8 years ago, and yes, it was, like I said, I've always been a small town girl. I never thought that I would go in a big city, far less to the other side of the planet. My first plane ride ever was from India to the US. So it was definitely hard, but I think I owe it all to my family. They've been very, very supportive in everything that I've done in my life, and education was always a very, very big part of my growth. With their blessings, I came to the U.S. and yes, it was hard. As a grad student for years, I wouldn't go back home I wouldn't get the opportunity to go back home for 2 or 3 years at a stretch. But you have to give up some things, but it's all good at the end.
It's a long and I'm sure expensive flight to get back there, so not the kind of thing you can just do every weekend. A couple more questions here, one from Gina in Virginia. When you were a kid, did you enjoy science? And students in Mrs. Bound's class ask, when did you start to enjoy studying science?
Thank you for those questions. So I think my mom and dad, they introduced me to mathematics and science perhaps when I was 3 or 4. Mathematics is the language of science, and growing up in India, I was taught that you never fear mathematics, you never fear science, and the world is your oyster if you get to learn mathematics and science. So I grew up loving science from the time that I remember, actually. So it was at a very, very young age, very formative years, that I learned about physics and chemistry and biology. Of course, minor processes, but I loved science even as a kid.
Awesome. Let's go to the other end of the spectrum with this question from Jenna. She wants to know, what's the highest level math course that you have taken?
That's an interesting question, Jenna. So the school system in India is very different from the school system here. All I can tell you is that many times when I would take mathematics classes as a grad student, I took a few mathematics classes, and many times the professor would start us teaching us something, and I had already learned that in my college. So the level is very rigorous back home in India. I believe that by the time you're in college, you probably have taken a very higher level courses in mathematics, so which includes algebra and trigonometry and geometry and anything that you can think of. So I grew up with that.
Mm-hmm. And what's the kind of math that you use on a regular basis now with your modeling and trying to figure out the conveyor belt system?
A lot of algebra, a lot of nonlinear equations, as we say, a lot of partial differential equations, which and a lot of higher level algebra and mathematics I use in my current study.
Okay, we're going to go next to a question from Kayla. Where was the first place you went to study the ocean when you began working as an oceanographer, I would assume?
Yeah, so I went to the Gulf of Mexico. That was the first place, the first time that I actually got to be on the ocean, and it was fascinating. Even though my research wasn't based in the Gulf of Mexico region, yet I got to learn how to measure the temperature of ocean water and how to measure the salinity of ocean water, how to collect data and samples. So it was a fascinating experience, but the Gulf of Mexico is what I call my home away from home.
Very nice. Andrea in Virginia, I think this is a follow-up to what you were just describing. I don't think she asked this before that, but how was the education system in India different from here in the United States? You talked a bit about how, the math, they're certainly moving faster in math than we're used to here, but what else might be different?
Sure. So thanks for that question, Andrea. So in India, you grow up so right from middle school. In fact, even before that, it's preschool probably what it's called in the US, but right from your formative school years, from grade 1 perhaps, all the way until grade 12. So K through 12, you have an intense mathematics and science-based curriculum. So you learn about history, geography, of course, you learn about English, you learn your own language, and then you also learn, you constantly keep on developing your mathematics and mathematics skills, and then it's not that you're not introduced to physics in one level. You're constantly, so in every grade you get a little bit of physics, a little bit of biology, a little bit of chemistry, and then you move up and you have, you build up on that. So that's a little bit more advanced. So an equivalent would be, so equivalent to K through 12 would be that you constantly, you're constantly building up right from kindergarten all the way through grade 12, whether or not you like it. You have no choice. So even if you want to be a history major or an English major, it's not, you don't have a science requirement. It is something that's a part of your curriculum. So you can't escape it. You have to learn it, and it becomes a part of your life, actually.
And you might be a little biased given your career path, but do you think that's a good thing?
I do think it's a good thing because I think that skills in science and mathematics, it opens the world for you. So I am completely supportive of students and friends and people who want to go ahead in other careers. I think we do need diversity. But at the same time, I think we do need a basic understanding of science, and the language that you use to conduct science is mathematics. So both of these streams, mathematics, science, engineering, technology. It's amazing how much you can learn about the world around you if you have some basic skills in these fields.
I could not agree more. So we're going to leave it at that for now. It's time to move on yet again in our program, and it's actually time. You've been asking Mona lots of questions, and she's been answering them. Mona has come up with some questions for you. So we're going to jump to our polls right now, and here's our first one. We're not going to spend too much time on this because we just talked a lot about it. I'm sure our audience out there knows the right answer, but our first poll question is, where did Mona grow up? A, Mexico, B, the United States, C, India, or D, the United Kingdom? Have you been paying attention, audience out there? We're going to give them just a couple of moments here to enter in their answers. I can see the results coming in. So far, 86% think India, unsurprisingly. There are a handful that are voting for Mexico, but I think they might just be doing that to be funny, because we've talked a lot about where you grew up. But for the most part, I'm looking at the results again. 91% are guessing C, India. Mona, is that the right answer?
That is the right answer.
I'm glad they were paying attention. So moving right along to our second poll question. This one is not quite as easy, and I don't think you have given the answer during this program. So here it is. How much of the Earth's surface is covered with oceans? Is it A, 17%, B, 52%, C, 71%, or D, 100%? What can you tell us about this by way of hints, Mona? What can we do to help our cause?
Well, we can definitely rule out D, isn't it? Because we wouldn't be here if we were if the Earth was covered entirely with the ocean.
We would certainly be very different
Yep.
if we were here. So if you're ruling out D, you've got a 30% shot basically at the other three. We're waiting for some additional answers to come in here. So far, 100% are guessing C, 71%. We haven't stumped anybody with the 100% response, but I don't think we've stumped anybody at all. Mona, what's the right answer?
The right answer is C. 71% of the Earth's surface is covered with the oceans.
And that is a lot.
Yes.
It is.
It's a
There's a lot of ocean out there to study. Let's jump to our third poll question. This is a true or false. And the statement is, the Earth's climate is changing. Is that a true statement or a false statement? And once again, we're going to give our audience just a few seconds here to enter in their answers. They can let us know if they think the Earth's climate is changing or not. We were talking earlier today, Mona, about, this is kind of a contentious issue within some groups. I'm not sure if you would include scientists in that group that thinks this is a contentious issue. There seems to be pretty strong consensus in one direction or another within that particular group. Looking at the answers coming in here, there are 7% of our audience think that is false.
Okay.
And 93% think that is a true statement. I'm going to go on a limb here and say the same people who were voting for false were the ones that thought you grew up in Mexico.
Okay.
So, Mona, is this a true or false statement? The Earth's climate is changing.
It is a true statement. So the Earth's climate changed in the past, it's changing in the present, and it will continue changing in the future too.
And I guess I should say the part of the contentious nature of that, whether it's true or false, is not necessarily is it changing, it is the cause of that change.
Absolutely.
Which is up for debate.
Yep.
With
Yeah,
certain people.
Yes, that's very true. Very true.
Okay, we're going to go to our last poll question here. Here it is. In which U.S. state did Mona go to school for her PhD? Did she go to school in Texas, Florida, Washington, D.C., or was it somewhere else entirely? Did she go to none of those states for her school? Answers are coming in already, and I don't, once again, I don't think you mentioned this at any part of the live broadcast, but it was in your questionnaire. If folks read that before the event, they might have a tip on the right answer. 75% of our audience at the moment are guessing Texas. They think that you probably got your PhD where you live and work right now. 25% think Florida. Nobody guessed C, Washington, D.C., potentially realizing that that is not a state, but a district. And nobody thinks none of the above. So slightly updated responses here. 67% think Texas, 33% think Florida. Mona, what is the correct answer?
So that's interesting. The right answer is B. Go Seminoles. I went to school at Florida State University in Florida. Yep.
And why did you choose to go there? You could have gone somewhere in Texas, correct?
Yeah, absolutely. Well, so when I was in India, that's actually an interesting question, Pat, because when I was in India and trying to realize what I wanted to do with my background in physics, I read the newspaper and I read about the scientist who gave an explanation, a scientific explanation for parting of the Red Seas. So I thought that that was fascinating, that you could explain, some of the biblical stories based on science. So it was fascinating to me, and that's how I got in touch with my professor, my former advisor, and he brought me in.
That is really interesting. I had never heard that. I have heard, actually, Jason's very own Dr. Bob Ballard has worked on some theories regarding the biblical flood and actual oceanographic theories on the basis of that. So, yeah, really cool stuff there. We're going to get back to our audience questions. Here's the next one here from Mrs. Dopa's class. I'm probably terribly mispronouncing that. But they ask, do you see yourself studying something different in the future? Maybe one of those other types of oceanography. What do you think? You going to stick with what you're doing, or you think you're going to venture somewhere else in the future?
That's a great question. I think, I keep an open mind. So I love to learn, keep an open mind. And if I never thought that I would be here doing, wearing all these different hats. So I would like to think that I would get an opportunity to learn something else, something new, and develop new skills and apply my skills in a whole different way. So yes, maybe yes.
You never know. All right. So Andrea's got our next question. Are there any oceanography activities for younger audiences to take part in?
Sure. Well, Andrea, again, thanks for that question. I can tell you about, the kind of activities that go on here at Texas A&M University and in the state of Texas. So there's something called the Texas Regional Collaborative for Science. I believe that there are such regional collaboratives for science just about everywhere. But there are so many hands-on activities for you to indulge in that may relate to the ocean. There are also many different programs. And Jason is actually one of those programs that you could participate in, to gather data, to participate in scientific research, and to learn. So there are many different opportunities available. It all depends on what you want to do. Do you want to be on the ship? Do you want a learning experience? Do you want to do some cool experiments related to the ocean and the atmosphere? There's a lot available.
All right, we've got more questions coming in. We're going to swing back around to some of the topics we covered at the beginning of the program. Michelle and Kelsey want to know, is it possible for the Greenland ice sheet to melt to the point of slipping into the ocean and ending the global conveyor belt? And if that's possible, could it happen soon?
Michelle, Kelsey, there is a possibility that anything could happen, but I don't have a scientific evidence. I don't think I've read of any scientific evidence that suggests that the entire Greenland ice sheet would melt in the future. It's definitely retreating. Arctic sea ice is melting, and Greenland ice sheets are retreating. But I don't think I'm at the moment I have enough evidence or that I am aware of that states that the entire Greenland ice sheet would melt. So I can't comment on that statement just as yet.
Okay. Let's see if you can comment on one of these statements. Sam from Virginia asks, is it possible for the Earth to have another ice age? And if so, is there anything that can be done to prevent it? And the Tulalip Boys and Girls Club, great to see you join us, Tulalip. Is it possible that if there is an ice age, that the animals might be able to cross to other places, other continents, using ice bridges? Or land bridges, should the water go low enough?
Very cool question. So, like I said, climate variability and change are a part of the Earth system. They have always happened in the past, and they are happening now, and they will continue to happen in the future. Yes, there is a possibility of ice ages. In fact, if you go back and look at observations, if you compare observations with models, and if you look at the physics of the Earth system, you would realize that there have been these glacial and glacial periods. So there have been times, what I'm trying to say, that the Earth was covered with ice, and then there have been times when there was no ice. So there have been these colder regions alternating with warmer regions. And that's the part of the system that happens. And yes, of course, there will be, there's a high possibility that there would be ice ages again. Human lifetime is just so small that we might not be able to anticipate or visualize these global climate changes. But, that's what happens. That is a part of the Earth system. So, and then when there would be ice ages, would there be ice bridges and animals might be able to cross? Well, who knows? Yes, there might be a possibility. I think that's probably, what might have occurred. Migrations have occurred in the past. People and animals have traveled from one part of the Earth to the other. And that will continue to happen should there be another ice age.
All right, we've got time for just a couple of more questions here. They keep on coming in, and they're such good questions. We want to keep on going, but we're starting to run out of time. Here's our next one from Bernardo in Virginia. He wants to know, what was your first reaction when you saw the ocean? You described before that you hadn't seen the ocean until you came here to study oceanography. What was that first experience like for you?
I think my heart was filled with gratitude, and I was very humbled. And it also made me realize, the the size of this human beings, are what's our role with the things that we take for granted. So water is one of those most beautiful elements of the earth that we take for granted, and yet it's just so integral to our existence. So I think I think personally, I mean, I was just amazed, and I felt that it was a profound moment in my life.
Pretty amazing. Brian asks, as somewhat of a follow-up here, how does your perspective on the ocean differ because you're a physics major? Do you look at water? Do you look at the ocean through a different lens than us ordinary folks?
I think it could be well. It's you could very well look at water and wonder about, is the water in the ocean steady, or is it moving, or why does the water sink, and why does it rises, or you may wonder about why is why are the poles colder, and you may wonder about heat exchange and whatnot. So I guess what I'm trying to get to is that I, of course, have a background in physics, and that makes me wonder. When I look at ocean water, I want to know what kind of physical processes occurred. How far deep in the ocean did this body of water travel, and how long did it take for this body of water to be where it is? So when I go to the beach and touch the ocean surface waves, I imagine, where are these waves coming from? So yes, a lot of physics that I imagine in my head, and I ask questions about, and I want to study. But it's also just general human curiosity. I think you could a chemist sitting right next to me on the beach might wonder about the chemical processes, and the biologist might wonder about biological processes. But so could my mom and dad, who are not scientists. So it's just, it depends on your perspective.
But unlike your mom and dad, you have some tools to actually go after those answers and inform the rest of us what's really going on. So time for two last questions here. This one's from Andrea. Are there any expeditions you're planning on going on soon?
Not at the moment. So I am trying to, in the future, I think. So we have the International Ocean Drilling Program right here on the campus of Texas A&M University. So I think we want to, together with IODP, Texas Sea Grants wants to, come up with an educational program for teachers. So there may be a possibility in the future, but not any at the moment.
Okay, and we're going to wrap up our event today with this question from Siggy. You talked before about 71% of the Earth is ocean, but how much of the ocean has been explored? And how does this relate to the work that you do?
Siggy, thank you so much for that question. I think that's a very, very important question. So we look at the planets and we wonder about the stars and the heavenly bodies. Yet we do not we do not know our own planet very much. Only 5 to 7% of the ocean floor has been explored. 93 to 95% of the ocean still remains unexplored. So that's a huge part of the 71% of the surface that we know is covered with water, and 93 to 95% of this 71% still remains unexplored. So it's a big part.
It's a big part, and we need more folks just like you to help us understand what's going on and how it all works and what exactly is out there on our very own home planet. So lots of work still to be done. I'm sure you have inspired some future oceanographers and scientists and explorers with all of your energy and enthusiasm today. Really appreciate you taking the time to join us, not once but twice in one day, to help spread the word to all of our Jason and Immersion audience out there. So thank you so much for taking the time.
It was a pleasure and honor to be here. Thanks to everybody.
Awesome. So we have a bit of a break coming up here after today's event at Jason Live, but our STEM career series continues in May and June. We'll be featuring 7 more career role models working in the fields of computer science, chemistry, ecology, and biotechnology. Keep an eye out on email and social media for announcements on our upcoming dates. You can connect with us on Facebook, The Jason Project, Twitter, Jason Learning, and of course for those of you involved in Immersion, you can connect with Immersion through Facebook and Twitter as well. And you can always go to jason.org/live where our full live event calendar is always posted. That is all for today. Once again, for Jason Learning, my name is Patrick Shea. We'll see you next time on Jason Live.